Good day everyone. Welcome to this presentation. I am Captain Ron Irani, and before we start, let me wish you all a very happy 2021. In this video I will be explaining the solution on pressure and thrust problems 1 to problem number 3 from exercise 2 in Captain Subramaniam's textbook Ship Stability 1. Before we start, let me explain that the pressure and thrust acting on any body is maximum at the keel, and as it rises, as the draft reduces, the pressure and thrust also reduce acting on the body. Of course, we can calculate the pressure and thrust for every millimeter or every centimeter or even for every meter of the draft. But that is a very tedious process, a very long drawn process. So what we always do is we calculate the pressure and thrust at half the draft. That gives us an average of the pressure and thrust going from the keel all the way up to the waterline. If you take a cylinder, also it will be at half the draft. If you take a circle, it will be at the center of the circle. If you take a triangle with its apex downwards, it will be at 2/3 of the draft from the apex or 1/3 of the draft from the base. And if you take a box ship vessel, it will also be at half the draft. So going on to problem number 1, we have to find the thrust experienced by a flat keel plate 10 meters by 2 meters when the draft is 8 meters in salt water. Sorry. So area of the flat keel plate is equal to length into breadth, and that is equal to 10 by 2 or 20 square meters. The pressure experienced by this flat keel plate from the bottom, from the sea, is equal to depth into density, and the depth being the draft 8 meters, the relative density being 1.025 of the sea salt water. That gives us pressure of 8.2 metric tons per square meter. Thrust, as we all know, is equal to pressure into area, and that works out to 8.2 into 20 equal to 164 metric tons. Going on to problem number 2. A box ship vessel 150 meters by 20 meters by 12 meters is floating in a dock of RD 1.010 at an even keel draft of 10 meters. Find the total pressure experienced by the hull. So here we have a box ship vessel, the dimensions being length 150 meters, breadth 20 meters, height 12 meters, and floating at a draft of 10 meters, that is at the red line shown in the diagram. We have to find the total water pressure exerted on the hull by the water. So we have to break this up into 3 parts. The first being the keel, the flat bottom, then being the vertical hull forward and aft, and also the vertical hull port and to starboard. When we work out for the vertical hull forward, we can just multiply it by 2 to get for the thrust on forward and aft vertical bulkheads. Likewise, on the port and starboard side, we can work for only one side, that is the port side, and multiply it by 2 to get the thrust on the hull on port and starboard sides. So thrust on the keel plate, as we saw in problem number 1, is equal to pressure into area, and pressure is equal to depth into the density. depth being 10 meters, that is the draft, and the density given to us is 1.010 in the problem. This works out to 10.1 metric tons per square meter. Area is equal to length into breadth of the keel, that is 150 by 20 equal to 3000 square meters. And we know the formula for thrust is equal to pressure into area. Thus we have 10.1 into 3000 is equal to 30,300 metric tons. This is part 1 of the solution. Going on to the part 2, for finding the thrust on the forward and aft hull. As I told you before we started this exercise, that we have to calculate pressure and thrust at half the draft. Hence, the depth, instead of taking the draft as 10 meters, we will take the depth as half the draft equal to 5 meters. Therefore, pressure is equal to depth into density equal to 5 into 1.010, and that gives us 5.05 metric tons per square meter. Area is equal to length into breadth equal to 20 by 10 equal to 200 square meters. This is the area on one side, either the port or the starboard side. Now the thrust, we're going to multiply it by 2 in pressure into area, and that gives us twice the product of pressure and area, 5.05 and 200, and that works out to 2020 metric tons. Now we calculate the pressure and thrust for the side hull on the port and starboard sides. Pressure is equal to depth into density. Again we take it at half the draft, that is 5 into 1.010 equal to 5.05 metric tons per square meter. Area of the hull on any one side is equal to length into breadth is 150 times 10 equal to 1500 square meters. When calculating the thrust, we take double the product of pressure and area, because thrust is going to be acting on both sides just as pressure is acting on both sides. So twice the product of pressure and area is equal to 2 into the product of 5.05 and 1500, giving us the thrust equal to 15,150 metric tons. Thus the total thrust on the hull is the sum of all these three answers that we have calculated for the keel, for the hull forward and aft, and for the hull on the port and starboard sides, thus giving us the total thrust on the hull equal to 47,470 metric tons. Going on to problem number 3 now. A submarine has a surface area of 650 square meters and can withstand a total water pressure of 13,32,500 metric tons. Find at what approximate depth in salt water she would collapse. This diagram here is the diagram of what a submarine would look like when seen from the front. Area given to us in the problem is 650 square meters. Thrust experienced by the submarine on its hull is 13,32,500 metric tons. It's floating in relative density salt water 1.025, and at what depth she will collapse is what we have to find out. We know the formula. Thrust is equal to pressure into area. Pressure P into area 650 is equal to 13,000 to 13 lakhs 32,500. Thus we find pressure is equal to 2050 metric tons per square meter. We know the formula for pressure equal to depth into density. Therefore, depth is equal to pressure divided by density, and we get depth equal to 2000 meters. Sorry. Trust you have understood the explanations to problems 1, 2 and 3 from exercise 2. Appreciate if you can give me a thumbs up, a like, share the video as well as subscribe to my channel. Thank you and goodbye.